everyone. Today we're going to continue with Chapter 12, Section 1, and we're going to look at Part 2. Here in this part, we're going to focus on a couple other forces. In the last section, we talked about balanced versus unbalanced forces, and we talked about friction. In this section, we're going to start off by talking about a force most of you guys should be familiar with, which is gravity. Gravity is a force because it is a pull that acts on any objects that have mass, so between any two masses. Gravity is actually considered an attractive force because it pulls things together, and one thing to note is gravity acts over very large distances. For example, our Earth has a mass and our Moon has a mass. And because the mass of Earth is so great, it has a pretty big gravity or gravitational pull. And so it is strong enough that it causes the moon to be attracted to Earth and causes our moon to actually circle around our Earth. Here is an image of a rock, and gravity is pushing down on this rock. So Earth exerts an attractive downward force on the boulder. And you've probably heard the phrase, what goes up must come down, because gravity is pulling things down. So even as you're sitting in class or walking outside, you have gravity or a push on your body. For example, you can try to jump up and Earth's going to pull you back down. This supporting rock exerts an upward force up on the bottom rock exerts a force up on the top rock, and gravity is going to push it down. Now, we say that these forces are balanced, and the reason they're balanced is because this object is not moving. This object is staying still, so our forces have to be balanced so it's not tipping over or falling, etc. So again, in what direction does Earth's gravity act? Again, Earth's gravity is an attractive downward force, so it's going to pull things down towards the center of Earth. Our next key question says, how do gravity and air resistance affect a falling object? Now, as a little bit of a precursor, air resistance we kind of hinted on a little bit in the last section. And we said that air resistance is a type of fluid friction when things go through air. So typically, gravity affects a falling object because it causes it to accelerate downwards. And we learned in chapter 11 that things in free fall or accelerates down to earth accelerates at a speed of 9.8 meters per second squared. So 9.8 meters for every second that it falls. Air resistance is a little bit different. Air resistance does not cause things to accelerate. In fact, it causes things to reduce acceleration. So this causes you not to fall to Earth as quickly. So both gravity and air resistance is going to affect a motion of an object, but it does so in opposite ways. Again, remember, as objects fall to Earth, they are going to accelerate and gain speed. Again, this is all due to gravity. However, if you remember when we went over dropping a pebble in a well, I said things cannot keep speeding up indefinitely. Eventually, they're going to reach something called terminal velocity, or terminal means the end. Velocity is another word for speed. So eventually, they're going to max out their speed. And they do this when the force of air resistance and the force of gravity equal each other out. So here's an example of gravity and air resistance working against each other. This animal over to the right is a flying squirrel. They take advantage of air resistance to slow its fall and increase its distance in a jump. So they have skin between their back and front paws, and that kind of acts as like a parachute. And when they act as a parachute, they're increasing their surface area. So my air resistance is actually having a pretty big effect here. And that air resistance causes it to stay in the air, even though gravity is pulling it down. So there are a couple things that I want you to add to your notes. First, air resistance increases as mass decreases, that means things that weigh less do not fall as quickly because air resistance is going to have better force to keep it up in the air. The other thing that we have to write down is air resistance increases as surface area increases. So when I say surface area, I'm talking like a parachute. The reason that if you had two pieces of paper and you have a flat piece of paper and a crumpled up piece of paper, the crumpled up piece of paper is actually going to fall faster because there's not as much air resistance or not as much surface area as the paper that is not crumpled. Another term that we're going to learn for air resistance and gravity is something called projectile motion, because we know that things do not fall straight down. Sometimes things are thrown or launched, and this usually follows the path of projectile motion. So a thrown ball follows a curved path. And this definition is defined as the motion of a falling object after it is given an initial forward velocity or an initial push forward or speed forward. For example, you throwing a ball. Air resistance and gravity are going to be forces that act on this projectile. Air resistance is still going to want to keep things up in the air, while gravity is still going to want to pull things down. So why exactly does the projectile follow a curved path? There are two reasons. First, we have to have that initial throw forward, and then we also have gravity pulling that ball down. So with these forces, when they combine, they tend to push forward and things fall down in a curve. Lastly, we're going to talk about these two images. The first image is if you had two masses, and these are in a vacuum. When I say a vacuum, there means there's no air. And that means there is no air resistance. If there was no air, meaning there was no air resistance, these two balls that are different masses would actually fall at the same rate. And that's because of gravity. However, if these two balls were not in a vacuum, we would see that the heavier ball would actually fall faster. Over here, the picture on the B, this is an example of free fall. So red is free fall versus projectile motion. Again, things in free fall will fall straight down, but if you have that initial forward velocity, this object's going to want to keep moving forward and gravity is going to want to keep moving it down, so we see that curved path. Okay. And that is the end of today's lesson. If you have any questions, please make sure you ask, and I hope you guys have a great day.